Hi there, this is Samuel, and I'm very excited that you're watching this video. And I'm equally glad that we were able to provide you a second part in AWS interview questions. If you haven't watched the first part yet, please go back and watch the first part. We have a lot of interesting questions there, which will better prepare you for the interview. All right, let's get started. So in an environment where there is a lot of automation, infrastructure automation, you'll be posted with this question: how can you add an existing instance to a new autoscaling group? Now, this is when you are taking an instance away from the autoscaling group to troubleshoot, to fix a problem, to look at logs, or if you have suspended the autoscaling, you might need to re-add that instance to the autoscaling group. Only then it's going to take part in it, right? Only then the autoscaling is going to count it as part of it. It's not a straight procedure. When you remove them, it doesn't get automatically re-added. And I've had worked with some clients when their developers were managing their own environment, they had problems adding the instance back to the autoscaling group. Irrespective of what they tried, the instance was not getting added to the autoscaling group, and whatever they fix that they were provided, or whatever fix that they have provided, were not getting counted in the autoscaling group. So like I said, it's not a straight a click button procedure. There are ways we'll have to do it. So how can you add an existing instance to the autoscaling group? There are a few steps that we need to follow. So the first one would be to, under the EC2 instance console, right, under the instance, under actions in specific, there's an option called attach to autoscaling group, right? If you have multiple autoscaling groups in your account or in the region that you're working in, then you're going to be posted with the different autoscaling groups that you have in your account. Let's say you have 5 autoscaling groups for 5 different applications. You're going to be posted with 5 different autoscaling groups, and then you would select the appropriate autoscaling group and attach the instance to that particular autoscaling group. While adding to the autoscaling group, if you want to change the instance type, that's possible as well. Sometimes when you want to add the instance back to the autoscaling group, there would be requirement that you change the instance type to a better one, to a better family, to the better instance type. You could do that at that time. And after that, you have completely added the instance back to the autoscaling group. So it's actually a 7-step process, adding an instance back to the autoscaling group. In an environment where they're dealing with migrating the instance, or migrating an application, or migrating an instance, migrating an VM into the cloud, if the project that you're going to work with deals with a lot of migrations, you could be posted this question: what are the factors you will consider while migrating to Amazon Web Services? The first one is cost. Is it worth moving the instance to the cloud? Given the additional bells and whistles features available in the cloud, is this application going to use all of them? Is moving into the cloud beneficial to the application in the first place? Beneficial to the users who will be using the application in the first place. So that's a factor to think of. So this actually includes cost of the infrastructure and the ability to match the demand and supply transparency. Is this application in high demand? Is it going to be a big loss if the application becomes unavailable for some time? So there are a few things that needs to be considered before we move the application to the cloud. And then if the application needs to be provisioned immediately, is there an urge? Is there an urge to provision the application immediately? That's something that needs to be considered. If the application requires to go online, if the application needs to hit the market immediately, then we would need to move it to the cloud. Because in on-premises, procuring, or buying an infrastructure, buying the bandwidth, buying the switch port, buying an instance, buying the softwares, buying the license related to it, it's going to take time, at least like 2 weeks or so, before you can bring up an server and launch an application in it, right? So if the application cannot wait, waiting means workforce productivity loss, is it? So we would want to immediately launch instances and put application on top of it. In those cases, if your application is of that type, if there is a urge in making the application go online as soon as possible, then that's a candidate for moving to the cloud. And if the application, or if the software, or if the product that you're launching, it requires hardware, it requires an updated hardware all the time, that's not going to be possible in on-premises. We try to deal with legacy infrastructure all the time in on-premises, but in the cloud, they're constantly upgrading their hardwares. Only then they can keep themselves up going in the market. So the cloud providers are constantly updating their hardwares. And if you want to be benefited, or if your application wants to be benefited by the constant upgrading of the hardwares, making sure the hardware is as latest as possible, the software version, the licensing is as latest as possible, then that's a candidate to be moved to the cloud. And if the application does not want to go through any risk, if the application is very sensitive to failures, if the application is very much tagged to the revenue of the company, and you don't want to take a chance in seeing the application fail and seeing the revenue drop, then that's a candidate for moving to the cloud. And business agility, moving to the cloud, at least half of the responsibility is now taken care by the provider. In this case, it's Amazon. At least half of the responsibility is taken care by them. Like if the hardware fails, Amazon makes sure that they're fixing the hardware immediately. And notifications, if something happens, there are immediate notifications available that we can set it up and make ourselves aware that something has broken, and we can immediately jump in and fix it. So you see, the responsibility is now being shared between Amazon and us. So if you want to get that benefit for your application, for your organization, for the product that you're launching, then it needs to be moved to the cloud so you can get that benefit from the cloud. The other question you could get asked is, what is RTO and RPO in AWS? They are essentially disaster recovery terms. When you're planning for disaster recovery, you cannot avoid planning disaster recovery without talking about RTO and RPO. Now, what's the RTO? What's the RPO in your environment? Or how do you define RTO? How do you define RPO? Are some general questions that get asked. RTO is recovery time objective. RTO stands for the maximum time the company is willing to wait for the recovery to happen, or for the recovery to finish when a disaster strikes. So RTO is in the future, right? How much time is it going to take to fix and bring everything to normal? So that's RTO. On the other hand, RPO is recovery point objective, which is the maximum amount of data loss your company is willing to accept as measured in time. RPO always refers to the backups, the number of backups, the frequency of the backups, right? Because when an outage happens, you can always go back to the latest backup, right? And if the latest backup was before 12 hours, you have lost the in-between 12 hours of data storage, right? So RPO is the acceptable amount. If the company wants less RPO is 1 hour, then you should be planning on taking backups every 1 hour. If RPO is 12 hours, then you should be planning on taking backups every 12 hours. So that's how RPO and RTO helps disaster recovery. The fourth question you could get asked is, if you'd like to transfer huge amount of data, which is the best option among Snowball, Snowball Edge, and Snowmobile? Again, this is a question that gets asked if the company is dealing with a lot of data transfer into the cloud, or if the company is dealing with migrating data into the cloud. I'm talking about a huge amount of data in petabytes. Snowball and all of the Snowball series deals with petabyte-sized data migrations. So there are three options available as of now. AWS Snowball is an data transport solution for moving high volume of data into and out of a specified AWS region. On the other hand, AWS Snowball Edge adds additional computing functions. Snowball is simple storage and movement of data, and Snowball Edge has a compute function attached to it. Snowmobile, on the other hand, is an exabyte scale migration service that allows us to transfer data up to 100 petabytes. That's like 100,000 terabytes. So depending on the size of data that we want to transfer from our data center to the cloud, we can rent any of these three services. Let's talk about some CloudFormation questions. This is a classic question. How is AWS CloudFormation different from AWS Elastic Beanstalk? From the surface, they both look like the same. You don't go through the console provisioning resources. You don't go through CLI and provision resources. Both of them provision resources through click button, right? But underneath, they are actually different services. They aid different services. So knowing that is going to help you understand this question a lot better. Let's talk about the difference between them, and this is what you will be explaining to the interviewer or the panelist. So the CloudFormation service helps you describe and provision all the infrastructure resources in the cloud environment. On the other hand, Elastic Beanstalk provides an simple environment to which we can deploy and run application. CloudFormation gives us an infrastructure, and Elastic Beanstalk gives us a small contained environment in which we can run our application. And CloudFormation supports the infrastructure needs of many different types of application, like the enterprise application, the legacy applications, and any new modern application that you want to have in the cloud. On the other hand, the Elastic Beanstalk, it's a combination of developer tools. They are tools that helps manage the life cycle of a single application. So CloudFormation, in short, is managing the infrastructure as a whole, and Elastic Beanstalk, in short, is managing and running an application in the cloud. And if the company that you're getting hired is using CloudFormation to manage their infrastructure, or if they're using infrastructure or any of the infrastructure as a code services, then you would definitely face this question: what are the elements of an AWS CloudFormation template? So it has 4 or 5 basic elements, right? And the template is in the form of JSON or in YAML format. Right, so it has parameters, it has outputs, it has data, it has resources, and then the format or the format version or the file format version for the CloudFormation template. So parameter is nothing but it actually lets you to specify the type of EC2 instance that you want, the type of RDS that you want, right? So EC2 is an umbrella, RDS is an umbrella, and parameters within that EC2 and parameters within that RDS are the specific details of the EC2 or the specific details of the RDS service. So that's what parameters in a CloudFormation template. And then the element of the CloudFormation template is outputs. For example, if you want to output the name of an S3 bucket that was created, if you want to output the name of the EC2 instance, if you want to output the name of some resources that have been created, instead of looking into the template, instead of navigating through in the console and finding the name of the resource, we can actually have them outputted in the result section. So you can simply go and look at all the resources created through the template in the output section, and that's what output values or output does in the CloudFormation template. And then we have resources. Resources are nothing but what defines what are the cloud components or cloud resources that will be created through this CloudFormation template. Now, EC2 is a resource, RDS is a resource, and S3 bucket is a resource, Elastic Load Balancer is a resource, and NAT Gateway is a resource, VPC is a resource. So you see, all these components are the resources, and the resource section in the CloudFormation defines what are the AWS cloud resources that will be created through this CloudFormation template. And then we have version. Version actually identifies the capabilities of the template. We just need to make sure that it is of the latest version type, and the latest version is 0909 2010. That's the latest version number. You'll be able to find that on the top of the CloudFormation template, and that version number defines the capabilities of the CloudFormation template. So just need to make sure that it's the latest all the time. Still talking about CloudFormation, this is another classic question: what happens when one of the resources in a stack cannot be created successfully? Well, if the resource in a stack cannot be created, the CloudFormation automatically rolls back and terminates all the resources that was created using the CloudFormation template. So whatever resources that were created through the CloudFormation template from the beginning, let's say we have created like 10 resources and the 11th resource is now failing, CloudFormation will roll back and delete all the 10 resources that were created previously. And this is very useful when the CloudFormation cannot, go forward. CloudFormation cannot create additional resources because we have reached the Elastic IP limits. Elastic IP limit per region is 5, right? And if you have already used 5 IPs and your CloudFormation is trying to buy 3 more IPs, we've hit the soft limit. Till we fix that with Amazon, CloudFormation will not be able to, launch additional, resources and additional IPs. So it's going to cancel and roll back everything. That's true with a missing EC2 AMI as well. If an AMI is included in the template but the AMI is not actually present, then CloudFormation is going to search for the AMI, and because it's not present, it's going to roll back and delete all the resources that it created. So that's what CloudFormation does. It simply rolls back all the resources that it created. I mean, if it sees a failure, it would simply roll back all the resources that it created. And this feature actually simplifies the system administration and layered solutions built on top of AWS CloudFormation. So at any point, we know that there are no orphan resources in our environment, because something did not work or because there was an, CloudFormation executed some, there are no orphan resources in our account. At any point, we can be sure that if CloudFormation is launching a resource and if it's going to fail and it's going to come back and delete all the resources it's created, so there are no orphan resources in our account. Now let's talk about some questions in Elastic Block Store. Again, if the environment deals with a lot of automation, you could be thrown this question: how can you automate EC2 backup using EBS? It's actually a 6-step process. To automate the EC2 backups, we'll need to write a script to automate the below steps using AWS API. And these are the steps that should be found in the scripts. First, to get the list of instances, and then the script that we are writing should be able to connect to AWS using the API and list the Amazon EBS volumes that are attached locally to the instance. And then it needs to list the snapshots of each volume, make sure the snapshots are present, and it needs to assign a retention period for the snapshot, because over time the snapshots are going to be invalid, right? Once you have some 10 latest snapshots, any snapshot that you have taken before that 10 becomes invalid because you have captured the latest, and 10 snapshot coverage is enough for you. And then the 5th point is to create a snapshot of each volume, create a new snapshot of each volume, and then delete the old snapshot. Anytime a new snapshot gets created, the oldest snapshot in the list needs to go away. So we need to include options, we need to include scripts in our script, lines in our script that make sure that it's deleting the older snapshots which are older than the retention period that we are mentioning. Another question that you could see in the interview, be it a written interview, be it online interview, or be it an telephonic or face-to-face interview, is what's the difference between EBS and Instant Store? Let's talk about EBS first. EBS is kind of permanent storage. The data in it can be restored at a later point. When we save data in EBS, the data lives even after the lifetime of the EC2 instance. For example, we can stop the instance and the data is still going to be present in EBS. We can move the EBS from one instance to another instance and the data is simply going to be present there. So EBS is kind of permanent storage when compared to instance. On the other hand, instance store is temporary storage, and that storage is actually physically attached to the host of the machine. EBS is an external storage, and instance store is locally attached to the instance or locally attached to the host of the machine. We cannot detach an instance store from one instance and attach it to another, but we can do that with EBS. So that's a big difference. One is permanent data and another one is EBS is permanent, instance store is volatile data, and instance store, with instance store we won't be able to detach the storage and attach it to another instance. And another feature of instance store is data in an instance store is lost if the disk fails or the instance is stopped or terminated. So instance store is only good for storing cache data. If you want to store permanent data, then we should think of using EBS and not instance store. While talking about storage on the same lines, this is another classic question. How can you take backups of EFS like EBS? And if you can take backup, how do you take that backup? The answer is yes, we can take EFS to EFS backup solution. EFS does not support snapshot. Like EBS, EFS does not support snapshot. Snapshot is not an option for EFS, Elastic File System, right? We can only take backup from one EFS to another EFS, and this backup solution is to recover from unintended changes or deletions of the EFS, and this can be automated. Right? Any data that we store in EFS can be automatically replicated to another EFS, and once this EFS goes down or gets deleted, or data gets deleted, or the whole EFS is for some reason interrupted or deleted, we can recover the data from, we can use the other EFS and bring the application to consistency. And to achieve this, it's not an one-step configuration, it's a cycle. There are a series of steps that's involved before we can achieve EFS to EFS backup. The first thing is to sign in to the AWS Management Console, and under EFS, or click on EFS to EFS restore button from the services list, and from there we can use the region selector in the console navigation bar to select the actual region in which we want to work on, and from there ensure that we have selected the right template. Some of the templates would be EFS to EFS backup, granular backups, incremental backups. Right, so there are some templates, the kind of backups that you want to take. Do you want to take granular? Do you want to take increment backups? Stuff like that. And then create a name to that solution, the kind of backup that we have created. And finally review all the configurations that you have done and click on save. And from that point onwards, the data is going to be copied. And from that point onwards, any additional data that you put is going to copy it and replicate it. Now you have an EFS to EFS backup. This is another classic question in companies which deals with data management. There are easy options to create snapshots, but deleting snapshots is not always an click button or a single step configuration. So you might be facing a question like, how do you auto delete old snapshots? And the procedure is like this. Now, as best practice, we will take snapshots of EBS volume to S3. All snapshots get stored in S3. We know that now. And we can use AWS Ops Automator to automatically handle all snapshots. The Ops Automator service, it allows us to create, copy, delete EBS snapshots. So there are CloudFormation templates available for AWS Ops Automator, and this Automator template will scan the environment, and it would take snapshots. It would copy the snapshot from one region to another region if you want, if you're setting up a DR environment. And not only that, based on the retention period that we create, it's going to delete the snapshots which are older than the retention period. So life or managing snapshot is made a lot easier because of this Ops Automator CloudFormation template. Moving into questions in Elastic Load Balancer, this again could be a question in the interview. What are the different types of load balancers in AWS, and what's their use case? What's the difference between them? And as of now, as we speak, there are three types of load balancers which are available in AWS. The first one being application load balancer. Just like the name says, the application load balancer works on the application layer and deals with HTTP and HTTPS requests. And it also supports path-based routing. For example, simplilearn.com / some web page, simplilearn.com / another website. So it's going to direct the path based on the / value that you give in the URL. So that's path-based routing. So it supports that. And not only that, it can support port-based :8080, :8081, or :8090, based on that port also, it can take a routing decision, and that's what application load balancer does. On the other hand, we have network load balancer, and the network load balancer makes routing decisions at the transport level. It's faster because it has very less thing to work on. It works on lower OSI layer. It works on a lower layer, so it has very less information to work with than compared with application layer. So comparatively, it's a lot faster, and it handles millions of requests per second. And after the load balancer receives a connection, it selects a target group for the default rule using the flow hash routing algorithm. It does simple routing, right? It does not do path-based or port-based routing. It does simple routing, and because of it, it's faster. And then we have classic load balancer, which is kind of expiring as we speak. Amazon is discouraging people using classic load balancer, but there are companies which are still using classic load balancer. They are the ones who were the first one to step into Amazon when classic load balancer was the first load balancer or the only load balancer available at that point. So it supports HTTP, HTTPS, TCP, SSL protocol, and it has a fixed relationship between load balancer port and the container port. So initially we only had classic load balancer, and then after some point Amazon said, instead of having one load balancer address all type of traffic, we're going to have two load balancers called as the child from the classic, two load balancer, and one is going to specifically address the application requirement and one is going to specifically address the network requirement, and let's call it as application load balancer and network load balancer. So that's how now we have two different load balancers. Talking about load balancer, another classic question could be, what are the different uses of the various load balancer in AWS Elastic load balancing? There are three types of load balancer. We just spoke about it. Application load balancer is used if we need flexible application management and TLS termination, and network load balancer if we require extreme performance and the load balancing should happen based on static IPs for the application. And classic load balancer is an old load balancer which is for people who are still running their environment from EC2 classic network. Now this is an older version of VPC, or this is what was present before VPC was created. EC2 classic network is what was present before EC2 was created. So they are the three types and they are the use cases of it. Let's talk about some of the security related questions you would face in the interview. When talking about security and firewall in AWS, we cannot avoid discussion talking about WAF, Web Application Firewall, and you would definitely see yourself in this situation where you've been asked how can you use AWS WAF in monitoring your AWS applications. WAF or Web Application Firewall protects our web application from common web exploits, and WAF helps us control which traffic source your application should be allowed or blocked, which traffic from a certain source, which source or which traffic from a certain source should be allowed or blocked to your application. With WAF, we can also create custom rules that blocks common attack patterns. If it is a banking application, it has a certain type of attacks, and if it is simple data management, data storage application, it has content management application, it has a separate type of attack. So based on the application type, we can identify a pattern and create rules that would actually block that attack based on the rule that we create. And WAF can be used for three cases. The first one is allow all requests, and then block all requests, and count all requests for a new policy. So it's also an monitoring and management service which actually counts all the policies or counts all the requests that matches a particular policy that we create. And some of the characteristics we can mention in AWS WAF are the origin IPs and the strings that appear in the request. We can allow block based on origin IP, allow block based on strings that appear in the request. We can allow block or count based on the origin country, length of the request. We can block and count the presence of malicious scripts in an connection. We can count the request headers, or we can allow block a certain request header, and we can count the presence of a malicious SQL code in a connection that we get and that want to reach our application. Still talking about security, what are the different AWS IAM categories we can control? Using AWS IAM, we can do the following. One is create and manage IAM users. And once the user database gets bigger and bigger, we can create and manage them in groups. And in IAM, we can use it to manage the security credentials, kind of setting the complexity of the password, setting additional authentications, like MFA, and rotating the passwords, resetting the password. There are a few things we could do with IAM. And finally, we can create policies that actually grants access to AWS services and resources. Another question you will see is, what are the policies that you can set for your user's password? So some of the policies that we can set for the user password is the minimum length, or the complexity of the password by at least having one number or one special characters in the password. So that's one. And then the requirement of a specific character types, including uppercase, lowercase, number, and non-alphabetic characters. So it becomes very hard for somebody else to guess what the password would be and try to hack them. So we can set the length of the password, we can set the complexity in the password, and then we can set an automatic expiration of the password. So after a certain time, the user is forced to create a new password, so the password is not stale, old, and easy to guess in the environment. And we can also set settings like the user should contact the admin when the password is about to expire. So you can get a hold of how the user is setting their password. Is it having good complexity in it? Is it meeting company standards? Or there are a few things that we can control and set for the users when the users are setting or recreating the password. Another question that could be posted in an interview, so to understand your understanding of IAM, is what's the difference between an IAM role and an IAM user? Let's talk about IAM user. Let's start small and then go big, or let's start simple and then talk about the complex one. The IAM user has a permanent long-term credential, and it's used to interact directly with AWS services. And on the other hand, IAM role is an IAM entity that defines a set of permissions for making AWS service requests. So IAM user is an permanent credential and role are temporary credentials. And IAM user has full access to all AWS IAM functionalities. And with role, trusted entities such as IAM users, application, or AWS services assume the role. So when an IAM user is given a permission, it sticks within the IAM user. But with roles, we can give permissions to applications, we can give permissions to users in the same account, in a different account, the corporate ID. We can give permissions to EC2, S3, RDS, VPC, and lot more. Role is wide, and IAM user is not so wide. It's very constrained only for that IAM user. Let's talk about managed policies in AWS. Managed policies, there are two types, customer managed and Amazon managed. So managed policies are IAM resources that express permissions using the IAM policy language. We can create policies, edit them, manage them separately from the IAM user group and roles which they are attached to. So they are something that we can do to managed policies if it is customer managed. And we can now update policy in one place, and the permissions automatically extend to all the attached entries. So I can have like 3 services, 4 services point to a particular policy, and if I edit that particular policy, it's going to reflect on those 3 or 4 services. So anything that I allow is going to be allowed for those 4 services. Anything that I denied is going to be denied for the 4 services. Imagine what would be without the IAM managed policy. We'll have to go and specifically allow deny on those different instances 4 or 5 times, depending on the number of instances that we have. So like I said, there are 2 types of managed policies. One is managed by us, which is customer managed policies, and then the other is managed by AWS, which is AWS managed policy. This question, can you give an example of an IAM policy and a policy summary? This is actually to test how well versed are you with the AWS console. The answer to that question is, look at the following policy. This policy is used to grant access to add, update, and delete objects from a specific folder. In this case, name of the folder is example folder, and it's present in a bucket called example bucket. So this is an IAM policy. On the other hand, the policy summary is a list of access level, resource and conditions for each service defined in a policy. So IAM policy is all about one particular resource, and the policy summary is all about multiple resources. With IAM policy, it was only talking about S3 bucket and one particular S3 bucket. Here it talks about CloudFormation template, CloudWatch logs, EC2, Elastic Beanstalk services. Summary of resources and the permissions and policies attached to them. That's what policy summary is all about. Another question could be like this: what's the use case of IAM and how does IAM help your business? Two important or primary work of IAM is to help us manage IAM users and their access. It provides secure access to multiple users to their appropriate AWS resources. So that's one it does. And the second thing it does is manage access for federated users. Federated users or non-IAM users, and through IAM we can actually allow and provide secure access to resources in our AWS account to our employees without the IAM user. Now, they could be authenticated using the Active Directory, they could be authenticated using the Facebook credential, Google credential, Amazon credential, and a couple of other credentials, third-party identity management, right? So we could actually trust them and we could give them access to our account based on the trust relationship that we have built with the other identity systems. All right, so two things. One is manage users and their access manage IAM user and their access in our AWS environment, and second is manage access for federated users who are non-IAM users. And more importantly, IAM is a free service, and with that we'll only be charged for the use of the resources, not for the IAM username and password that we create. Alright, let's now talk about some of the questions in Route 53. One classic question that could be asked in an interview is, what is the difference between latency based routing and GeoDNS or geo-based DNS routing? Now, the geo-based DNS routing takes routing decisions on the basis of the geographic location of the request, and on the other hand, the latency based routing utilizes latency measurements between networks and data centers. Now, latency based routing is used where you want to give your customers the lowest latency as possible. So that's when we would use latency based routing. And on the other hand, geo based routing is when we want to direct customers to different websites based on the country they are browsing from. You could have 2 different or 3 different websites for the same URL. Take Amazon, the shopping website, for example. When we go to Amazon.com from in the US, it directs us to the US web page where the products are different, the currency is different, right, and the flag and a couple of other advertisements that shows up are different. And when we go to Amazon.com from India, it gets directed to the Amazon.com Indian site, where again the currency, the product, and the advertisements, they're all different, right? So depending on the country they're trying to browse, if you want to direct customers to 2 or 3 different websites, we would use geo-based routing. Another use case of geo-based routing is if you have a compliance that you should handle all the DNS requests, or if you should handle all the requests from a country within the country, then you would do geo-based routing. Now, you wouldn't direct the customer to a server which is in another country, right? You would direct the customer to a server which is very local to them. That's another use case of geo-based routing. And like I said, for latency-based routing, the whole goal or aim is to achieve minimum end-user latency. If you are hired for the architect role and if that requires working a lot on the DNS, then you could be posted with this question: what is the difference between domain and a hosted zone? A domain is actually a collection of data describing a self-contained administrative and technical unit on the internet, right? So for example, Simplilearn.com is actually a domain. On the other hand, hosted zone is actually an container that holds information about how you want to route traffic on the internet to a specific domain. For example, lms.simplilearn.com Simplylearn.com is an hosted zone, whereas Simplylearn.com is an domain. So in other words, in hosted zone, you would see the domain name plus a prefix to it. LMS is a prefix here. FTP is a prefix. Mail.simplylearn.com is a prefix. So that's how you would see a prefix in hosted zones. Another classic question from Route 53 would be, how does Amazon Route 53 provide high availability and low latency? The way Amazon Route 53 provides high availability and low latency is by globally distributed DNS servers. Amazon is a global service and they have DNS services globally. Any customer doing a query from different parts of the world, they get to reach an DNS server which is very local to them, and that's how it provides low latency. Now, this is not true with all the DNS providers. There are DNS providers who are very local to a country, who are very local to a continent. So they generally don't provide low latency service. Right, it's always high latency. It's low latency for local users, but anybody browsing from a different country or a different continent, it's going to be high latency for them. But that's not again true with Amazon. Amazon is a globally distributed DNS provider. It has DNS servers global wide, and like I said, it has optimal locations. It has got global servers, or in other words, it has got servers around the globe, different parts in the globe, and that's how they are able to provide high availability. And because it's not running on just one server but on many servers, they provide high availability and low latency. If the environment that you're going to work on is going to take a lot of configuration backups, environmental backups, then you can expect questions in AWS Config. A classic question would be, how does AWS Config work along with AWS CloudTrail? AWS CloudTrail actually records user API activity on the account, and any HTTP, HTTPS access, or any sort of access that's made to the cloud environment, that's recorded in the CloudTrail. In other words, any API calls, the time is recorded, the type of call is recorded, and what was the response given? Was it a failure? Was it successful? They also get recorded in CloudTrail. It's actually a log. It actually records the activity in your cloud environment. On the other hand, config is a point-in-time configuration details of your resources. For example, at a given point, what are all the resources that were present in my environment? What are all the resources, or what are the configuration in those resources at a given point? They get captured in AWS Config. Right? So with that information, you can always answer the question, what did my AWS resource look like at a given point in time? That question gets answered when we use AWS Config. On the other hand, with CloudTrail, you can answer the question, by looking at the CloudTrail, or with the help of CloudTrail, you can easily answer the question, who made an API call to modify this resource? That's answered by CloudTrail. And with CloudTrail, we can detect if a security group was incorrectly configured and who did that configuration. Let's say there happened to be a downtime, and you want to identify, let's say there happened to be a downtime and you want to identify who made that change in the environment. You can simply look at CloudTrail and find out who made the change. And if you want to look at how the environment looked like before the change, you can always look at AWS Config. Can AWS Configure or AWS Config aggregate data across different AWS accounts? Yes, it can. Now this question is actually to test whether you have used AWS Config or not. I know some of the services are very local, is it? Some of these services are availability zone specific, some of them are regional specific, and some of them are global services in Amazon. And though some of the services are region services, you still can do some changes, add some configuration to it and collect regional data in it. For example, S3 is a regional service, but still you can collect logs from all of the regions into an S3 bucket in one particular region. That's possible. And CloudWatch is an regional service, but still you can, with some changes to it, with some adding permissions to it, you can always monitor the CloudWatch that belongs to CloudWatch logs that belongs to other regions. They're not global by default, but you can do some changes and make it global. Similarly, AWS Config is a service that's a region-based service, but still you can make it act globally. We can aggregate data across a different region and different accounts in an AWS config and deliver the updates from different accounts to one S3 bucket and can access it from there. AWS Config also works or integrates seamlessly with SNS topic. So, anytime there is a change, anytime a new data gets collected, you can always notify yourself or notify a group of people about the new log or the new config or new edit that happened in the environment. Let's look at some of the database questions. Database should be running on reserved instances. So whether you know that fact or not, the interviewer wants to understand how well you know that fact by asking this question. How are reserved instances different from on-demand DB instances? Reserved instances and on-demand instances are exactly the same when it comes to their function, but they only differ based on how they are built. Reserved instances are purchased for 1 year or 3-year reservation, and in return we get a very low per hour pricing because we're paying upfront. It's generally said that reserved instance is 75% cheaper than on-demand instance, and Amazon gives you that benefit because you're committing for 1 year and sometimes you're paying in advance for the whole year. On the other hand, on-demand instances are built on an hourly price. Talking about autoscaling, how will you understand the different types of autoscaling? The interviewer might ask this question: which type of scaling would you recommend for RDS and why? There are two types of scaling, as you would know now, vertical and horizontal. And in vertical scaling, we can vertically scale up the master database with a couple of clicks. Alright, so that's vertical scaling. Vertical scaling is keeping the same node and making it bigger and bigger. If previously it was running on T2 micro, now we would like to run it on M3, 2 times large instance. Previously it had 1 virtual CPU, 1 gigabit. Now it's going to have 8 virtual CPU and 30 gigabit of RAM. So that's vertical scaling. On the other hand, horizontal scaling is adding more nodes to it. Previously it was running on 1 VM. Now it's going to run on 2, 3, 10 VMs. Right, that's horizontal scaling. So database can only be scaled vertically, and there are 18 different types of instances we can resize our RDS to. Right, so this is true for RDS MySQL, Postgres SQL, MariaDB, Oracle, Microsoft SQL servers. There are 18 type of instances we can vertically scale up to. On the other hand, horizontal scaling are good for replicas. So they are read-only replicas. We're not going to touch the master database. We're not going to touch the primary database, but I can do horizontal scaling only with Amazon Aurora, and I can add additional read replicas. I can add up to 15 read replicas for Amazon Aurora and up to 5 read replicas for RDS MySQL, Postgres SQL, and MariaDB RDS instances. And when we add replica, we are horizontally scaling, adding more nodes, right? Read-only nodes. So that's horizontal scaling. So how do you really decide between vertical and horizontal scaling? If you're looking to increase the storage and the processing capacity, we'll have to do a vertical scaling. If you're looking at increasing the performance or of the read-heavy database, we need to be looking for horizontal scaling, or we need to be implementing horizontal scaling in our environment. Still talking about database, this is another good question you can expect in the interview. What is the maintenance window in Amazon RDS? Will your DB instance be available during the maintenance event? Right, so this is really to test how well you have understood the SLA, how well you have understood the Amazon RDS, the failover mechanism of Amazon RDS, stuff like that. So RDS maintenance window, it lets you decide when a DB instance modification, a database engine upgrades, or software patching has to occur. And you actually get to decide, should it happen at 12 in the night, or should it happen at afternoon? Should it happen early in the morning? Should it happen in the evening? You actually get to decide. And automatic scheduling by Amazon is done only for patches that are security and durability related. Sometimes Amazon takes down and does automatic scheduling if there is a need for a patch update that deals with security and durability. And by default, the maintenance window is for 30 minutes. And the important point is the DB instance will be available during that event because you're going to have primary and secondary, right? So when that upgrade happens, Amazon would shift the connection to the secondary, do the upgrade, and then switch back to the primary. Another classic question would be, what are the consistency models in DynamoDB? In DynamoDB, there is eventual consistency read. This eventual consistency model, it actually maximizes your read throughput. And the best part with eventual consistency is all copies of data reach consistency within a second. And sometimes when you write and when you're trying to read immediately, chances that you would still be reading the old data. That's eventual consistency. On the other hand, there is another consistency model called the strong consistency or strongly consistent read, where there is going to be a delay in writing the data, making sure the data is written in all places, but it guarantees one thing, that is, once you have done a write and then you're trying to do a read, it's going to make sure that it's going to show you the updated data, not the old data. You can be guaranteed of it that it is going to show the updated data and not the old data. That's strongly consistent. Still talking about database, talking about NoSQL, DynamoDB or NoSQL database, which is DynamoDB in Amazon. You could be asked this question: what kind of query functionality does DynamoDB support? DynamoDB supports get and put operation. DynamoDB supports, or DynamoDB provides flexible querying by letting you query on non-primary key attributes using global secondary index and local secondary indexes. A primary key can be either a single attribute partition key or a composite partition sort key. In other words, a DynamoDB indexes a composite partition sort key as a partition key element and a sort key element. And by holding the partition key, when doing a search or when doing a query, by holding the partition key element constant, we can search across the sort key element to retrieve the other items in that table. And the composite partition sort key should be a combination of user ID partition and a timestamp. So that's what the composite partition sort key is made of. Let's look at some of the multiple choice questions. Sometimes some companies would have a written test or an MCQ type online test before they call you for the first level or before they call you for the second level. So these are some classical questions that companies ask in their multiple choice online questions. Let's look at this question. As a developer, using this pay-per-use service, you can send, store, and receive messages between software components. Which of the following is being referred here? Let's look at it. Right, we have AWS Step Functions, Amazon MQ, Amazon Simple Queue Service, Amazon Simple Notification Service. Let's read the question again. As a developer, using this pay-per-use service, so the service that we are looking for is a pay-per-use service, you can send, store, and retrieve messages between two software components, kind of like a queue there. So what would be the right answer? It would be Amazon Simple Queue Service. Now, Amazon Simple Queue Service is the one that's used to decouple the environment. It breaks the tight coupling and then it introduces decoupling in that environment by providing a queue or by inserting a queue between two software components. Let's look at this other question. If you would like to host a real-time audio and video conferencing application on AWS, right? It's an audio and video conferencing application on AWS. This service provides you with a secure and easy to use application. What is this service? Let's look at the options. They are Amazon Chime, Amazon Workspace, Amazon MQ, Amazon AppStream. You might tend to look at Amazon AppStream because it's real-time and a video conference, but it's actually for a different purpose. It's actually Amazon Chime that lets you create chat and create a chat board and then collaborate with the security of the AWS services. So it lets you do the audio, it lets you do the video conferencing, all supported by AWS security features. It's actually Amazon Chime. Let's look at this question. As your company's AWS Solution Architect, you are in charge of designing thousands of individual jobs which are similar. Which of the following service best serves your requirement? AWS EC2 Autoscaling, AWS Snowball, AWS Fargate, AWS Batch. Let's read the question again. As your company's AWS Solution Architect, you are in charge of designing thousands of individual jobs which are similar. it looks like it's batch service. Let's look at the other options as well. AWS Snowball is actually an storage transport service. EC2 Autoscaling is introducing scalability and elasticity in the environment, and AWS Fargate is container services. AWS Batch is the one is being referred here that actually runs thousands of individual jobs which are similar. AWS Batch is the right answer. Right, let's look at the other one. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are we referring to? So we have Amazon SageMaker, AWS Deep Lens, Amazon Comprehend, AWS Device Farm. Let's read the question again. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are referred here? The answer is SageMaker. It provides every developer and data scientist with the ability to build, train, and deploy machine learning models quickly. That's what SageMaker does. Now, for you to be familiar with the products, I would recommend you to simply go through the product description. There's one page available on Amazon that explains all the products, quick, neat, and simple. That really helps you to be very familiar with what the product is all about and what it is capable of. Is it a DB service? Is it a machine learning service? Or is it a monitoring service? Is it a developer service? Stuff like that. So get that information, get that details before you attend an interview, and that should really help to answer or face such questions with great confidence. So the answer is Amazon SageMaker, because that's the one that provides developers and data scientists the ability to build, train, and deploy machine learning models quickly as possible. All right, let's look at this one. Let's say that you are working for your company's ID team and you are designated to adjust the capacity of the AWS resource based on the incoming application and network traffic. How do you do it? So what's the service that actually helps us to adjust the capacity of the AWS resource based on the incoming application? Let's look at it. Amazon VPC, Amazon IAM, Amazon Inspector, Amazon Elastic Load Balancing. Amazon VPC is a networking service. Amazon IAM is an username password authentication. Amazon Inspector is a service that actually does a security audit in our environment. And Amazon Elastic Load Balancer is a service that helps in scalability. That's in one way, indirectly that helps in increasing the availability of the application, right? And monitoring how much requests are coming in through the Elastic Load Balancer, we can actually adjust the environment that's running behind it. So the answer is going to be Amazon Elastic Load Balancer. All right, let's look at this question. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon's servers. So we have Amazon GameLift, Amazon Greengrass, Amazon Lumberyard, Amazon Sumerian. Let's read the question again. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon servers. The answer is Amazon Lumberyard. This Lumberyard is an free AAA gaming engine deeply integrated with AWS and Twitch with full source. This Lumberyard provides a growing set of tools that helps you create an highest game quality applications. And they connect to a lot of games and vast compute and storage in the cloud. So it's that service they are referring to. Let's look at this question. You are the project manager of your company's cloud architect team. You are required to visualize, understand, and manage your AWS cost and usage over time. Which of the following service will be the best fit for this? We have AWS Budgets, we have AWS Cost Explorer, we have Amazon Workmail, we have Amazon Connect. And the answer is going to be Cost Explorer. Now, Cost Explorer is an option in the Amazon console that helps you to visualize and understand and even manage the AWS cost over time. Who's spending more? Who's spending less? and what is the trend, what is the projected cost for the coming month. All these can be visualized in AWS Cost Explorer. Let's look at this question. You are a chief cloud architect at your company, and how can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? So we have a CloudFormation as a service, we have AWS Aurora as a solution, we have AWS Autoscaling, and Amazon API Gateway. Let's read the question again. You're the chief cloud architect at your company. How can you automatically monitor and adjust computer resources? How can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? This is an easy question to answer. The answer is autoscaling. Right, that's a basic service and solution architect course, is it? Autoscaling is the service that helps us to easily adjust, monitor, and ensure the maximum performance and efficiency of all scalable resources. It does that by automatically scaling the environment to handle the inputs. Let's look at this question. As a database administrator, you will use a service that is used to set up and manage databases such as MySQL, MariaDB, and Postgres SQL. Which service are we referring to? Amazon Aurora, Amazon Elastic Cache, AWS RDS, AWS Database Migration Service. Amazon Aurora is Amazon's flavor of the RDS service, and Elastic Cache is the caching service provided by Amazon. They are not full-fledged database. And database migration service, just like the name says, it helps to migrate the database from on-premises to the cloud, and from one database flavor to another database flavor. Amazon RDS is the service, is the console, is the service, is the umbrella service that helps us to set up, manage databases like MySQL, MariaDB, and Postgres SQL. It's Amazon RDS. Let's look at this last question. A part of your marketing work requires you to push messages onto Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. So the options are AWS CloudTrail, AWS Config, Amazon Chime, AWS Simple Notification Service. All right, it says a part of your marketing work requires you to push messages. It's dealing with pushing messages to Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. It's Simple Notification Service. Simple Notification Service is a message pushing service. Right? SQS is pulling. Similarly, SNS is pushing. Right? Here it talks about a pushing system that pushes messages to Google, Facebook, Windows, and Apple through API, and it's going to be a simple notification system or simple notification service. That's all I had. 40 interesting interview questions in part 2, and I'm sure when you really understand the background of the question and how to answer the question, I'm sure you will be able to crack the interview and get the job that you've been waiting for. And we are very glad that we were able to provide such thoughtful questions and answers. We were able to collect, design such thoughtful and answer questions and provide it to you so you can prepare well and move forward in your career. It's Samuel from Simplilearn. Thank you again. We'll meet you in another video as soon as possible. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.